Good morning, everybody. If anybody comes in, be sure and let them know there's plenty of seats in the back. So, yeah, maybe it's a little early for some folks this morning, but good morning. Welcome to the Lithium battery panel. My name is Tim Rogers, and I am the Director of Very Dangerous Goods for UPS, and I'll introduce our panel here in a second. First off, I did want to thank Ben and IATA for asking me to moderate the panel, and appreciate IATA and Ben for everything they've done this week for WCS. I'd also like to thank LATAM Cargo for their sponsorship, as well as ICA for the sponsorship of this panel. So thanks to all involved for their work this week. Also, if you have looked at the panel agenda over the past couple of weeks, you will see that we've been very dynamic on our list of participants. Two colleagues from the Middle East were not able to make it, Michael Kalashal of Qatar and Trevor Howard of Emirates, so they send their apologies and regrets, but obviously we understand why they're not here, so I'm filling in for Michael and Ben is filling in for Trevor. So we are the B team. So, ask your questions appropriately. Just, we're not the first choices, but no, I'm just kidding. So, we do expect more people to show up as they roll in. We do appreciate you being here. We know there are choices. Hopefully, everybody had a good time last night at the gala. And looking around the crowd, I'm not going to call anybody out specifically, but since this is a battery panel, I think those here, maybe you're at about 30, 40, 50% state of charge right now, hitting the regulatory threshold a little bit. Feel free to get up and go upstairs and get some coffee, come back, maybe your energy levels will elevate, we'll hit about 80, 90% state of charge. So, this is we're gonna do our panel maybe a little different than some of the other panels. As you can tell, I'm not up at the podium. We want this to be a very, I don't want to say low key, but more of a chat, more of a conversation. We do want some interaction. Batteries are always a big topic. We're not going to solve the world today on, lithium battery issues, but we want to have a open, honest conversation. We do, the panelists do have some presentations. They do want to cover some points, but we do want to have a open, honest conversation. That's how we want to set this up. So it's not up here to be a lecture. So hopefully you guys will feel very free to ask your questions, and we'll have a conversation between the stage and the tables. So I'll start off with a few opening comments, and then we will probably have a couple of kickoff questions, and then we'll get into the presentations that will flow today. So whether you represent a cargo or passenger airline, a freight forwarder, a regulatory body, a shipper, or even a consumer, lithium batteries touch everything in our lives. They're in our pockets, they're in our homes, in our workplaces, they're even in our vehicles. Essentially everything we rely on. Batteries are always in the headlines. Despite decades of regulation, training, and consumer education, lithium batteries still test our limits. And we still continue to talk about them at every forum, every meeting that we have that involves dangerous goods. In the dangerous goods world, batteries, we're not talking about ethyl alcohol, dry ice, or even radiopharmaceuticals. Those are very important topics, but for the most part, they are well contained through regulation and established procedures. Not saying they're not a concern, but they do not constantly come up like lithium batteries do. Today, we will take a stroll following our theme that was published through the past, present, and future of lithium batteries. each of our panelists will take one of those topics and work through the past, present, and future. We will work through that and tell a story to understand the challenges ahead and understand where we've come from, where we are now, and with the emerging technologies and regulation changes, where are we going in the future? So I will, at this time, introduce our panel. We have Ben Firkins, Head of Cargo Safety and Dangerous Goods at IATA. We do have a doctor in the house, Dr. Emily Bremsek, from Senior Manager of Qualitative Insights, UL Standards and Engagement. Hopefully we don't have any medical emergencies. I don't know if that's not the type of doctor that Emily is. But, and then we have Remco Dardenne, Head of Air Operations, Belgian Civil Aviation Authority. I'll kick it off to get it going with just a question open to each of our panelists, whoever wants to go first, and just briefly touch on how you started in dangerous goods. How did you get into this industry?
So the old guy goes first. For me, it was 1994, and that was when dangerous goods were starting to be exposed. Australia had one person assigned to looking after dangerous goods. We were in 3 regions. Australia is quite a large country, and somebody came to me and said, we'd like you to do some dangerous goods for us. The job was being done by flight operations inspectors. Pilots are good at flying aircraft. They're not very good at cargo, and even less good at dangerous goods. So that was where I first started. It was a 2-day course, and that was learning the dangerous goods regulations, and it was the IATA one, not the ICAO one. And then I observed a flight operations inspector do one surveillance event on a freight forwarder, and then he observed me, and that was it. I was competent. I was let loose on the industry. And after that, it was my license to learn, and it's been a non-stop journey there. And the other thing I'll say back in 1994 was, my thought was, I don't want to be doing this when I'm 65. And here I am, 62, and still doing it.
Yeah, Remco.
Right. Well, I started 15 years ago, directly with the Belgian Civil Aviation Authority as a dangerous goods auditor. And maybe it's quite similar to what you said, Ben. I replaced somebody who was not there anymore, so I did not have any support on getting competent. So I had to find out myself lots of things in the world of dangerous goods, but was very happy to have some colleagues from the other modes of transport to guide me. And then I changed position to dangerous goods coordinator, which meant that I was leading a team of 1. So in Belgium, we did not have that many people involved in the transport of dangerous goods by air. But it was a nice experience to then make somebody else also competent on the auditing and safety oversight on dangerous goods. I immediately got a chance to work together in the dangerous goods panel under the ABIS group with the Dutch delegation. So I learned a lot there. I'm still working together with them in the dangerous goods panel. And then I was also, while being at the dangerous goods panel, which is of course the, let's say, the international forum where all the regulations are discussed on the safe transport of dangerous goods by air. We also have a European forum, and I'm the secretary of that forum. And then the similar situation that occurred in the CEA occurred also at the Federal Public Service of Mobility and Transport, meaning that people that did the oversight on other modes of transport left. So also the international representation of those fora was absent. And then I got the chance to participate at the UN subcommittee of experts on the transport of dangerous goods, which make the multimodal recommendations. And since last year, I've been elected chairman of that group. So yeah, it has been quite a journey, and I'm happy to be here. In general, it's a bit early after the gala dinner, but yeah, that's my story.
Thanks, Remco. Emily?
Hi, so I have a bit of a different background from the other panelists here today. I am with an organization called UL Standards and Engagement. We have been around for about 120 years, and we've been really primarily focused on fire safety, electrification, and emerging technology. So all of those components kind of coalesce around the issue of lithium batteries. UL was founded originally during the first electrification revolution as an organization to support insurers to incorporate this emerging technology into buildings. We think that we're now sort of at the beginning of a second electrification revolution, and there are new risks emerging. So our work deals with these risks across not only cargo aviation, but the broader the broader cargo space, as well as these risks in our communities and our homes. So I'll be coming from that perspective today when I'm talking about the work that we're doing.
So let me just ask the room here for a second. You know, just by a show of hands, who thinks lithium battery safety will get harder over the next decade? Just by a show of hands. Okay, about half the room. All right, we'll see what our panel thinks as we work through it. Let's start off with another easy question I'll throw to the panel, and then we'll get into the presentations. But to get this going a little more lively here. So if lithium batteries could talk, we complain about batteries all the time as an industry, and the batteries never get to actually give their side of the story. So if you think lithium batteries could talk, what do you think their biggest complaint about the supply chain would be from a battery perspective? So, by the way, these are not pre-posed questions. I just surprised the panel with this question, so they're probably scrambling a little bit. I'll get that payback later. But so if lithium batteries could talk, what would they say about us in the supply chain? So we'll start with Ben.
Yeah, good question. Thanks, Tim. I think they probably look at it from the consumer perspective and the use and abuse that they get put through. When we think about batteries, they can actually sit on the shelf for a long time, and they're very happy and they're very stable, and nothing ever happens to them. You never hear of batteries going into a thermal runaway just because it's sitting on a warehouse shelf. It's when people start using them. So it'll be the likes of Tim, who takes the battery by surprise and makes it do things that it was never intended to do, whether it's being modified or being dropped or being overcharged or being left on overnight. So I think that would be from a battery perspective, where my biggest complaint would be. It'd be owners like Tim.
Remco?
Well, thank you for the question. And also thank you, Ben, for giving me some time to think about an answer. I think the biggest complaint would be how long do we, as batteries, still have to be the hottest topic in air transport? What changes need to be done that we are considered as a safe and secure article that can be transported in a safe and secure way? And I think that's also something that will come up in our presentations, that there are existing quality standards. We have packaging, defined packaging requirements, and I could continue with some other requirements, but I mean, what else needs to be changed that batteries are considered as another dangerous good?
Emily?
Okay, well, first I'd like to point out that I think IATA has a passenger message campaign called If Batteries Can Talk, so you guys can check that out. And I think they're telling you not to put them in your checked luggage when you're flying, and you all would agree with that. But I think probably what I would say is batteries feel very misunderstood by the average user. And What I mean by that is they are a consumer product that is proliferating rapidly. We're surrounded by them right now. We have been tracking public understanding and sentiment of battery and battery risk for about the last 3 years at UL Standards and Engagement. And we found that only about 50% of people really know what a lithium-ion battery is, what a lithium battery is, and what they actually power. So a lot of people don't really have any sense of the prevalence of these batteries in our lives. But I think more importantly, they do not have any real sense at all of the risk of a battery going into thermal runaway. I think largely when people are concerned about battery health, they're concerned about them losing charge quickly, that type of thing. People are not really perceiving the true risks of the thermal runaway that can happen not only in aviation, but in your home, in your community.
Yeah, that's, I mean, I think back, well, if I ask the question myself, I guess I'll answer. But I mean, I think back from when my kids are little and they spilled something or something like that, they point to each other. Oh, it wasn't me, it wasn't me. So the good batteries are pointing to the bad batteries. Or the good manufacturers are pointing to the bad manufacturers, saying, why are you coming down on all of us? And then the bad ones are actually denying and trying to hide. So they probably wouldn't admit that in public. But no, I think that's a good icebreaker question. So actually now, Ben, if you're ready, I'll turn it over to you for our first presentation. And Ben is going to cover a hazardous history of transporting lithium batteries. He's going to guide us through the moments from the past and the safety landscape we operate into today. So take it away, Ben.
Thank you, Tim. Well, I've already done this, so we'll move through that. We've got the Lithium Battery Forum by WCS26. Thank you very much. And we also have the AI-powered summary that's available on the app. So you will find it on the app. It'll give you a summary as the meeting progresses. And then for those of you for whom English is not your first language, on the IATA app, there is a translation tool. I have to say I am very impressed with it. It is very good. And Pia will be able to attest to it as well in terms of its translation into Finnish. Yeah, it's good. It's really, really good. So on to me. So as we touched on, my journey started in 1994. My first lithium battery incident was 1996. And I'll touch on that in a little bit. When we come to it, my first lithium battery forum was an IATA one in 2008 run by Dave Brennan in Shanghai. So the early days, what did it look like? Well, as I said, we started in, I started in 1994. First incident was 96. And the provisions for dangerous goods then were still pretty much as they are now, leaving aside batteries. You had to consider 3 things when it came to transporting dangerous goods by air, and that was temperature, pressure, and vibration. Temperature of, I think it was minus 40 to plus 55, pressure at 95 kPa, and a vibration of 50 hertz. But that didn't actually apply to batteries at that stage. 2003 was when we saw the UN 38.3 series of tests actually start coming in, and then we had 3 incidents in 2006. So the first one was the UPS incident in Philadelphia, and I might take a little bit of revenge on Tim and ask Tim, when did he actually get involved with dangerous goods?
Good question. And I was actually moved to the department. I could not spell DG. I didn't even know that we moved hazmat, which we call that in the United States. And it was 3 weeks exactly before that incident in Philadelphia. And I sat there and I was like, what in the have I done? So yeah, 3 weeks before that was my indoctrination into dangerous goods and batteries.
And the story of that particular incident was the crew were airborne. They were coming up towards descent, and the flight engineer, I think it was, noticed that there was a bit of a burning smell. And that was the first indication. There was no fire warning, no smoke alert. It was just the crew smelt something burning. And then a few minutes later, more of them started noticing it, and so then they pulled out the emergency codes and so on. Managed to land the aircraft, pulled up to the gate, evacuated, and unfortunately they survived. But time from start of the fire to loss of the airframe, 23 minutes. 23 minutes from noticing smoke to losing the aircraft. Next incident was 2010, so that was the one in Dubai, again UPS, and that was also my first ICAO dangerous goods panel meeting, which was about a couple of months later. Unfortunately, the crew didn't survive that one. Based on records, the time between the first indication of fire and loss of the aircraft was 27 minutes. That was it, 27 minutes. And then in 2011, we had Asiana Airlines, and that was 17 minutes from indication of fire to loss of the airframe and loss of the crew on board. And so for a cargo world, these were actually very tragic accidents. Very fortunate that they didn't happen on passenger aircraft, but it did focus the world's attention on lithium batteries, particularly for ICAO. So the consumer batteries have been growing. Demand, it grows around about 22% annually. As Tim mentioned at the beginning, it's in your pockets, it's on your wrist, it's in your laptop, it's in your bag, it's everywhere, it's all around you. It's a cheap source of energy. And we use it because we can pack so much energy into it that they last a long time. But it does come with risks. And most of you are familiar with a lot of this, so I won't go over the basic physics of it. And here's a few examples. And the first thing I'll say is, I'm not Trevor. I stepped into this at the last minute. And part of it, me stepping into the last minute, was I was actually hiking in the hills and I had no reception. So I do have to thank my colleagues for putting the deck together for me. But so here we've got some old examples of lithium battery incidents that we do see happening. And it's the obvious ones. Laptops catching fire, batteries being mishandled and damaged, and then we'll come on to some more recent examples shortly. But the challenge is trying to find it. When you've got shipments like this, where do you find the lithium batteries in there? The hidden and misdeclared is a big problem. It's a real big safety problem from our perspective. But enough of the problems. I said I would talk about my first incident, and my first incident was one of these. It was, and Dave Brennan was actually working for the airline at the time that had the incident. So small world, 1996. And it was a delivery van, so the batteries had already flown. They'd flown from Perth to Sydney in Australia, put into the back of a van, the driver was taking out to be delivered, and the back of the van started smoking. And so he was able to escape. And fire brigade were called, they put it out, and then they investigated it. And then they said, okay, it's come from Perth. Ben, congratulations, you got 2 years experience on the job. Go investigate it. And so part of the investigation was going and speaking to the shipper. And then when I spoke to the shipper, they said, yeah, we sent it, but we didn't pack it. It was packed by a different company. So then I go and talk to the company that packed it. And they said, yes, we were given the order to fulfill. So, and he described to me how he packed it. I said, well, why did you pack it that way? And he said, well, it was just going to be delivered 3 kilometers down the road to the other business. I never knew it was going to go by air. I would have never have packed it that way if it was going to go by air. And so for me, that was a good experience into the different people in the supply chain and all the assumptions that get taken when we're transporting cargo and dangerous goods. We assume that the person that is next in the supply chain knows what we've done and will do the right thing carrying it forward. Likewise, the people in the supply chain assume that the people before them have also done the right thing. There's a lot of assumptions that run in transporting cargo. So that was my first lithium battery incident. I would like to say it was my last. I can't. But so far I've taken us up to 2011 and the loss of Asiana Airlines. And we tend to think of lithium batteries being problematic with passengers and with cargo. But in 2013, we actually had a different problem. 2013 saw the introduction of the 787 Dreamliner. 2013 was when we had ANA and Japan Airlines, and it was a brand new aircraft, had a lithium, the aircraft battery was a lithium-ion battery. With both of those aircraft, they started experiencing smoking events. Fortunately, no loss of life. And then later on that year, we had a 787, an Ethiopian 787, and that was a lithium metal battery that was in the emergency locator beacon installed in the tail. And again, very fortunate that it was on the ground when it started shorting out. The material surrounding the emergency locator transmitter caught fire, and the fire propagated. Lucky it was at the airport, the fire brigade were there and were able to put it out. And so where I'm going with all of this is for every action, for every incident, we then start building equal and opposite regulations that will try and stop that incident happening again. And so we saw airworthiness rules getting tightened up. And as part of the investigation, the aircraft manufacturer did come in for some closer scrutiny on their assessment of batteries, their assessment of risks, their consideration of emergency responses. So that takes us up to 2013. And then we get to 2015. So up until then, the rules have been evolving, and I think Remco and I were both on the dangerous goods panel at the same time, watching these rules evolve year by year. Every meeting, lithium batteries was on the agenda, and it was all about how do we tighten it and make it safer. So at the time, lithium-ion batteries, UN 3480, there was actually 3 packing groups within it. I call them packing groups, they're not. But it was Section 1A, Section 1B, and Section 2. And what was happening was the industry had worked out that it could use this Section 2 structure, and they were filling boxes with mass batteries packed together. It wasn't a safe situation, and so 2015, we tightened the rules and said, okay, that's it. Section 2 for packing instruction 965, that's gone, it's been removed. And then also we introduced the 30% state of charge. 30% state of charge is where batteries are far less likely to go into thermal runaway, and it's probably one of the greatest safety mitigations that we can have for shippers who comply. If your batteries are at 30% state of charge or less, they're not going to go into a thermal runaway. And then in terms of state of charge, we come forward to 2025, and that's when for lithium-ion batteries packed with equipment, we went the same way. Initially, it was a recommendation for 12 months, and then we made it mandatory. So the supply chain had time to prepare shipments and make them safer too. And so far, this has all been cargo and a couple of aircraft ones. January 2025 in Korea was our first real experience of the loss of an airframe for a lithium-ion battery carried by a passenger. One power bank. One power bank was enough to cause the loss of a $250 million aircraft. So that focused a lot of attention at the ICAO level last year, with a lot of work being done on A, power banks, and B, lithium battery-powered mobility devices, wheelchairs. I'll leave the wheelchairs for now, but in terms of the power banks, so several papers went forward, and for consideration, there was a lot of discussion. The discussion's still happening, but ICAO is actually moving quite quickly, and later on this month, early next month, there will be an amendment that will limit power banks to 2 per passenger. At the moment, there is no limit. A passenger can legally take as many power banks as they want. IATA does have a soft limit of 20, but We adjusted the guidance material at the beginning this year to get ahead of ICAO so we can start educating passengers so they get used to the idea that it's 2 power banks. For us, power banks are currently our biggest safety concern when it comes to passengers. Yes. And then we come on to the other piece that we're trying to deal with. So it's when it comes to a cargo side, we have the containers, they're sitting underneath the passengers. That's where there's been a lot of work from, not just from IATA, but from a lot of industry manufacturers. We've got the EOD forum in a neighboring room. And we've got the SAE Age 2 group that's looking at trying to develop standardized tests for fire-resistant containers and fire containment covers. We know we're not going to be able to stop all non-complying batteries. So what are the tools and methods that we can come up with that do make it safer for us? When we look at the occurrence data, the events when things go wrong, the vast majority of the incidents that we see are passenger related. And I think it goes back to Tim's question, if I was a battery, what would I be saying? And that's, my answer is based on the incident data. What do I see? It's the number of incidents that happen because of passengers. But why do we get worried about cargo? We get worried about cargo because we carry much bigger volumes together. And the concern is that one cell in a battery, in a box of batteries, in a pallet of boxes of batteries, one cell can be enough to cause the whole lot to go into thermal runaway. That's why we get worried. And that's where the rules are heading, that we try to make it better. And hopefully that'll lead on to shortly into Emily's presentation. But for now, I'm happy to take any questions. Here's your chance. You got a microphone somewhere? Go on, Helen. You know you want to. No? No questions? Excellent. I'll get an easy one. James, bane of my life.
Thank you for the introduction, Ben. Good morning, everybody. James White from AeroConcept. Thank you for the very nice panel and also presentation. Something which you mentioned in your presentation, I'm not sure what the real answer is when you say, what is e-commerce? Because I think that question is still open within the supply chain. What really is it? You're absolutely right that hidden, undeclared dangerous goods when it comes to lithium batteries is, of course, the biggest risk. And if we talk about e-commerce, you have the levels of consignments under a master airway bill, a house airway bill, shipment level on a individual tracking number if I'm an express integrator, and the level goes further down in terms of the big consolidations. So the incidents that you've seen, whether that's in a warehouse, whether that's on an airport apron or in an aircraft, they're already in the supply chain. And we discussed yesterday at length for those people that were in the room yesterday afternoon concerning the upcoming changes to Annex 18, which will give the regulator more oversight. So the question, I guess, is, do we see in the future that due to deeper regulatory oversight for dangerous goods in general, they're the changes for Annex 18, will this really have a positive impact also then on the topic of lithium batteries, because that oversight will be deeper in the supply chain and therefore catch the potential rogue shipper or the incident before the stages that we've seen with those incidents?
Thank you. That's a good question that covered a lot of points. And I think I might actually start off with, before the rogue shipper, let's deal with the good shippers, Tim's favourite, the people who do try to operate in compliance. That was my experience as a regulator. Generally, if people know the rules and they know there's a chance they're going to get caught, they will try to do the right thing. And as a regulator, I generally took the view was that if you were trying to do the right thing, even if you got it wrong, I would still give you credit. We might have a conversation, we might have some education, but if you went in with the mindset of, I want to do this correctly, then I would work with you. When we look at the supply chain, there is a focus where regulators, and it does stem back to Annex 18, and regulators and states do have to oversight the operator. IATA has been looking at the supply chain for a long time, and some regulators do look further down the supply chain. Like I said, 1994, my first audit was a freight forwarder, a domestic freight forwarder. I started looking at Australia Post in 2002, well before it became a requirement in 2011 to even start looking at postal authorities that could accept lithium batteries contained in equipment in the post. So some regulators will take the initiative to look further down the supply chain. They will go and look at shippers. I used to go and audit pathology labs to see how they were preparing their materials and was it in compliance with Packing Instruction 650? Did they have staff that were trained? And most of the time it was, yes, they were trying to do the right thing. It was an easy piece. Yeah. But in terms of, I will keep focusing on the compliant ones. So IATA has been looking at it for a while, and they've got a number of programs, so the CEIV lithium batteries, so that includes shippers, freight forwarders, operators, airports. You've got whole ecosystems that are trying to come together to say, yes, lithium batteries being shipped out of this city is important for us. Everybody is going to be doing this program. Everybody will be on board with it. And there's a strong degree of faith and reliance that they are doing the right thing, a very strong community. There's other ones in Shanghai where we're looking at a trust community. Again, it's based on an airport ecosystem, but they're working together. And again, that's freight forwarders, cargo terminal operators, very close cooperation and understanding of their business models. Who are the good freight forwarders? Who are the not so good ones? The freight forwarders know where they rank in that system. And the incentive there is for the ones that don't perform as well to lift their game. The 6 operators in that program don't know the ranking of the freight forwarders. The 6 operators do not know which are the good forwarders and which are the bad ones. But they know the cargo terminal operator knows. And that's where they have a lot of faith that the right things are being done. But to come on to the road piece, I'm going to skip that question. I'm going to pass it over to Emily, who's going to take us a little bit more about the broader elements of the supply chain and how we can work there. Thank you.
Right. Good morning. Okay, so I've already given you a little bit of a background on who I am, where I'm coming from. Today I'm here to talk to you about a new report that we just launched this week on Tuesday here at the World Cargo Symposium called Rising Incidents, Shifting Responsibility, Lithium Batteries in the Aviation Cargo Supply Chain. So when I was talking about UL standards and engagement and where our areas of focus are, one thing I neglected to mention is that we actually are a standards development organization. That means we develop safety standards, consensus standards that are internationally adopted for a number of products and technologies that you use on a daily basis. Probably most of you in this room who have a computer can look at the back of the power brick that comes with your laptop, and you'll see a little circle with a UL in it. That means that it conforms to our internationally recognized standard and was tested to do so by a testing laboratory. About 6 years ago, we realized that there was a rising number of incidents with lithium batteries in aviation. So we started the Thermal Runaway Incident Program, where airlines can join as voluntary members and provide their thermal runaway incident data to us. We then can kind of aggregate it, work with various regulators to get a sense of what's going on, and provide information back to industry about where we're seeing areas of risk. Then about 3 years ago, we realized that we were describing the problem, but we weren't fully solving it. So we started a program of sort of wraparound research to understand not only what is happening as regards these batteries, but also why these incidents are on the rise and how we might support the industry in mitigating them. We first started in the aviation space focused on passengers. The vast majority of our incidents are happening in the cabin, and this is largely due to the fact that passengers are bringing many batteries with them on board when they board an aircraft. As I already mentioned, they have no idea what they're bringing with them. We have done a lot of work on that side to understand kind of what passengers need to know to do better, to pack safer, how cabin crew are responding to these incidents, how they're firefighting. And in the last year, we decided to turn our attention to cargo aviation and the risks that these batteries pose in the cargo supply chain. Ben identified a number of incidents that have had really negative consequences from thermal runaway, and we wanted to see how we can identify where the risk is actually situated in the supply chain, as well as how we might move forward to mitigate that risk. So in order to investigate this issue a little more thoroughly, we took a mixed methods approach where we combined our trip incident data over the last 6 years with multiple touch points with those in the cargo aviation industry. This includes numerous operators, international regulators, representatives from the battery manufacturer industry, as well as shippers, where I think a lot of the risk is situated. We tried to speak with both large-scale shippers as well as down to the individual drop shipper to get a sense of their understanding of batteries as a dangerous good. As I mentioned too earlier, we also do tracking surveys on general public understanding of this risk, and so we have incorporated some of that data into our report as well. There are 4 key takeaways that I want to walk you through today. The first is that thermal runaway incidents in cargo continue to rise alongside rising consumer demand for battery-powered products. The second is that we found that battery quality and shipper behavior are the core drivers of risk within the supply chain. Third, we see that geographic variation in oversight as well as approaches can add to this risk, and that's a theme I've heard pretty consistently across this conference when I've attended to other panels. And finally, we see that the system is built on trust, but it's also built on plausible deniability, which means that there's a lot of shifting accountability and responsibility for this risk. Now, I'm going to walk you through each of these findings in a little more depth, and then end with a set of recommendations that I'd love to have the opportunity when we get to the questions later to discuss as a group. Okay, so here's just kind of an overview of our cargo data from 2021 to 2025. We see broadly thermal runaway incidents are on the rise, and it is a relatively steady increase rather than episodic. I think that this is important to note because we know for a fact that operators are evolving their mitigations to this risk, and yet the risk is still rising. We think that this is likely due to some underlying structural factors related to consumer behavior, and I'm going to talk about those in a moment. First, I wanted to dig into this data a little bit more. We see that there are 65 events reported between 2021 and 2025, with a 40% increase over that period. There has been a 9% rate of average annual growth in the number of incidents. To us, this is really concerning. Ben mentioned the Air Busan incident where they lost an aircraft. We are, hoping to prevent any further catastrophic events by supporting industry with this data. So I mentioned that underlying structural factors is our hypothesis for why risk is continuing to increase, even though airlines are attending very strongly to this risk. We see that there is rapidly growing consumer demand for battery-powered products. There's a proliferation of third parties, and this is sort of across the board in terms of third parties. There are new manufacturers who are kind of deviating from the larger scale manufacturing that we see in larger brands. We see freight forwarders and other people moving these batteries through the supply chain. But I think more importantly, and related to the third point, we see the rise of a lot of small sellers and shippers who are really unaware of the risk of this dangerous good. They are able to do this largely through e-commerce, through drop shipping, through opening small e-commerce shops, by sourcing their supplies around the world, and then just shipping them to the consumer with very little knowledge in a lot of cases of what is actually the risk of this product. And finally, because this is such a consumer-driven product, potentially in contrast to other dangerous goods, this means that there's some cost compression factors across the supply chain. Particularly with these new entrants into the battery marketplace, we see people wanting to get things to customers as cheaply and as quickly as possible. And that, of course, can introduce risk when you have such a volatile product. Okay, so now I want to talk about what we see as the core drivers of risk and where they're situated in the supply chain. When we talk to stakeholders across the board, regardless of what perspective they held, whether they were a battery manufacturer or whether they were a regulator, whether they were an operator, they consistently identified two core drivers of risk. The first is battery quality. And when I mean battery quality, I'm talking about everything from how the battery is manufactured to the conditions in which it's manufactured, the testing it undergoes, whether or not it actually conforms to an international standard, either one of ours or from another standard development organization, whether the testing laboratory is even a registered and appropriate testing laboratory, and also where the battery is in its life cycle. So older used batteries, we have less sense of the battery health. Then the other side of the coin that we heard consistently was shipper behavior. So this was the extent to which people who are moving these batteries through the supply chain are actually in compliance with the current regulations. I mean, the regulations as they stand, do spell out pretty explicitly that these batteries need to be declared, labeled, marked, packaged appropriately, but we see that shippers are operating across a very wide spectrum of compliance when it comes to these regulations. And again here, I just can't emphasize enough, this is so different from other dangerous goods in a lot of ways because of this consumer demand for the product and the entrance of all of these third parties into the supply chain. I wanted to share two perspectives with you now. One's from a regulator, one's from a battery manufacturer. They're actually in agreement with each other, which did not happen often in my research. But in this case, the regulator said there's a lot of trust. There always has been in dangerous goods, trust that everybody's doing what they're supposed to be doing. But I think with these consumer products, the chances of things not being in compliance are greater than they were for things like chemicals that we traditionally shipped by air. So this regulator here is again pointing out that consumer element of the issue. I also want to put a pin in this notion of trust, and I'm going to return to that later in the conversation. We also heard from the battery manufacturer that in their perspective, consumer demand for the way that these products perform is also driving risk. They told us there's so much demand for just more and more and more. There are breakthroughs being made, but sometimes I think those breakthroughs see the light of day a little earlier than they should, just because there is that pressure for more and more power. So essentially, consumers want products that charge quickly, that last longer, that have more power, and manufacturers are trying to meet that demand, but not necessarily within the structure of standards and regulations. So sort of, in the ideal state of the air cargo transportation process flow for lithium-ion batteries, we would have a pretty straightforward journey from the OEM to the end user. That would allow for opportunity, for significant oversight to that the OEM and any subsequent shippers are complying with all international regulations. It would also provide some, assurance to the end user that the product that they're getting coming, to them from across the world is going to be safe to have in their home or in their community. That's actually not what is happening with lithium-ion batteries. It's really more like a pinball machine, I would say. Like they're just sort of pinballing around the world, going from OEM to additional manufacturers to various distributors, through e-commerce sites to the consumers. A lot of times they're going back in the other direction too, when consumers are returning batteries, refurbishing them, and any number of other reasons. So each of these lines with the arrows going in either direction sort of represent the ideal supply chain potentially, but we see that there's an opportunity to introduce risk at every point in the supply chain when it comes down to what is the quality of the battery, but also how has the shipper prepared that battery for shipment. We also heard very frequently that geography amplifies risk. So we are able within TRIP to kind of track, when we have origin data, to track where these incidents are happening, where they are originating from the batteries themselves. We see that 42% of the incidents have origins in Asia. That's where we have the destination reported. More than half of the reported cargo incidents have their origin there. But Asia also accounts for the largest share of global volume of production of batteries. So we think that the data, is probably relatively normalized, although we haven't done that normalizing yet. So when I say that geography amplifies risk, what I'm not doing is talking about a particular state, a particular policy, or a particular approach. What I'm talking about, rather, is that the variation itself is what a lot of stakeholders perceive to be the risk driver. So Stakeholders identified 3 risks most frequently when I talked to them. The first was geography, the second was manufacturer credibility, so that's getting to the battery quality piece, and the third was miss or undeclared batteries, which is getting to the shipper behavior piece. I also was able to run correlations with how our stakeholders were talking about these risks. And we see that geography as a risk was highly correlated in their perspective with manufacturer credibility, third-party involvement, and misdeclaration. So essentially, they don't think that we're getting the same level of kind of battery quality or declaration from all regions of the world. We also saw that geography was correlated with some other topic areas separate from risk. In particular, industry practices, oversight, enforcement, and regulations. So again here, and I think this is echoing something I've heard consistently this week, that just differences in approach is where risk is introduced rather than the approach itself. The final key finding is around this idea of how the system is actually approaching oversight. So ultimately what we found is that the system relies on trust rather than verification when it comes to oversight and enforcement. In the shipping compliance and enforcement triangle, we have 3 key parties: regulators, operators, and shippers. Regulators are, of course, responsible for creating the regulations and driving from the top down the way in which we can move batteries safely through the supply chain. Shippers are theoretically responsible for fully educating themselves and complying with these regulations, both in the state that they're based in as well as where they're moving the batteries to across the world. Operators are the ones who are taking on the most risk because they are the ones actually loading these batteries onto planes. And so they are responsible for ensuring essentially that shippers are in compliance, as well as reporting non-compliance to regulators for possible enforcement. What we heard pretty consistently across all the conversations is that there's relatively high confidence in oversight itself. I think that's due to the fact that oversight is perceived as a shared responsibility across this triangle, with no parties really feeling particularly solely responsible for it. We heard, though, that in enforcement, there is significantly less confidence because people do not think that they're catching all of the non-compliance in the supply chain. The other really important point here is that when it comes to oversight, when I say it's perceived as a shared responsibility, what we really heard is that operators feel like they have too much responsibility for oversight. They are, as a result, required to identify reactive mitigations like fire containment, detection, suppression on airplanes, but also proactive mitigations like shipper surveillance so that they can trust that what they're putting into their aircraft is what it says it is on the box. So when it comes to shipper surveillance, we heard that airlines broadly have similar ideas about what makes them feel that a ship is likely to be compliant or non-compliant. And essentially what happens is that these serve as proxies for actual oversight. So when we have someone who has a pattern of manufacturing to internationally recognized standards, testing in registered labs, when we see somebody whose shipments always show up completely pristine, labeled correctly, packaged correctly, when we see a large brand, airlines are more likely to be confident in compliance there. All of these are proxies for compliance. We also see that this is perceived to be largely an overlap among these groups. If you're doing one of these things right, you're perceived to be doing many of these things right. On the flip side, we heard that there were sort of 4 key areas that raise red flags for operators. The first is small and individual shippers, which we talked about a little bit already, which is these drop shippers and people who do not have a traditional dangerous goods background. The second, and highly related, is shippers who are selling through e-commerce platforms. Another is shippers who are using middlemen as they move their product through the supply chain. So again, that pinball effect of complicating the battery's journey. And finally, shippers who are moving used or refurbished batteries around the world just simply because we don't know enough about the battery health. Let's see. In addition to airlines solving this problem individually, around shipper surveillance, we also heard that there was kind of a lack of harmonization in other areas. So we heard from airlines we know what we're doing, we're not sure what the person over there is doing, and ours is probably the best, right? So there's not harmonization, there's not necessarily information sharing. We also heard that there's not harmonization around fire containment certification approaches. So essentially, how are we solving for this? What is technologically and the safest response? We heard that there's really inconsistent training and oversight of shipper education in particular around the globe. And then we heard that there's inconsistencies on information sharing and best practices. As a standards development organization, we love harmonization. I mean, that's kind of our thing. So we have a number of standards, UL 1642, 2056, 2054, that are designed to keep these batteries safe through their entire life cycle. So when they're moving through the supply chain, as well as when they're with the end user in your home or community. More recently, we've begun to develop standards for fire safety products in aviation. So we have UL 5800, which is our standard for battery fire containment products. Many passenger airlines and some cargo operators are using these for small-scale lithium-ion batteries in the cabin or in the flight deck. And we are also now working on UL 5810, which is going to be a standard for fire-resistant ULs for lithium-ion batteries. So I want to end with a set of recommendations that have emerged from these findings, and I'm hoping we'll have a chance to discuss them a little bit later. The first is to establish clear, enforceable responsibility across the entire supply chain. This includes defining and enforcing accountability at each transfer point, reducing diffusion of responsibility across the various intermediaries, and attaching consistent consequences to non-compliance to eliminate this plausible deniability. I didn't have enough time to talk about this today, but we did some frankly kind of frightening conversations with small shippers that are US-based, and what we heard from them really consistently, especially the folks who are drop shipping, is like, if this package blows up, it's down to the manufacturer. It has nothing to do with me. I'm just simply importing it into this country. We have people importing batteries from manufacturers in Asia that are arriving to them in compliance with regulations. They're repackaging them in their own packaging that are no longer compliant because they have no idea what the regulations are. Then again, they do not think they're doing anything wrong. Like, they really do not think that this is their fault, that there's any responsibility for them at all. The second recommendation is to strengthen education and global industry coordination. So deliver simplified, accessible guidance tailored to these small and third-party shippers where we think a lot of this risk is situated. Align oversight and inspection practices across modes and jurisdictions, and improve data sharing and visibility on shipper compliance history. And our final recommendation is to align cost and safety. So the other thing that I thought was interesting about this sort of consumer-driven demand and the consumer driving of this risk is that the cost and safety equation functions very differently for large brands than it does for brands. Large brands see safety as highly tied to their reputation, and so they are going to often err on the side of safety at the expense of cost. On the flip side, these smaller brands are much less concerned with safety. They're very concerned with cost because it's a highly competitive marketplace, and they want to undercut the other consumer. And I think even on, you can look on any e-commerce site. You can see the same product, probably manufactured in the same factory, being sold under multiple different names for slightly different prices, and all of those shippers are engaging in different shipping practices to get that product from its OEM to their end user. And then, with aligning costs and safety, our sort of sub-recommendations are to harmonize product safety standards and enforcement, align regulatory frameworks to reduce economic incentives for this corner cutting, and promote the adoption of proven safety standards to reduce the upstream risk. Our full report is available at the QR code. We also have a number of hard copies available for those of you here at the symposium. My colleague Matt and I carried them from the US in our suitcase, and we will not be them home, so I'd love each of you to take one of them with you. It's much lighter than the 75 I had. But if you don't want to do that, you can go ahead and read it online. We have a lot of other research collateral on the website as well. Great, thank you. Are we taking questions? Oh, are there any questions? I think I have a couple of minutes to take questions before Remco. All right, I guess I was very clear.
I'll throw one. Sorry, I'll throw a question for Emily. Hello, 1, 2, 1, 2. Ah, good. So when you talked about the plausible deniability and the operators said, we know what we're doing well, but we've got no idea what's happening up the supply chain. Label Master and IATA do a dangerous goods confidence survey each year, and last year we put in some questions, looked at the supply chain side. And what it found was that there was, again, a high degree of faith in the individual parties in the supply chain and what they're doing, very little faith in the people upstream are doing the right thing. There was more faith in the regulator, and by that I mean the general dangerous goods regulator for all modes of transport, and then even greater faith in the actual aviation regulator. From your perspective, how do regulators take that information and strengthen the supply chain? How do they get people having more trust and faith in their supply chain partners who are upstream feeding goods into them?
I mean, I think that's a difficult question, because if it were easy, it would be done, right? But I think, to me, what it comes down to is I think you're right. What we heard too is that there is broadly confidence in regulations themselves, right? We didn't hear we heard, there were some regulatory insufficiencies. Different parties had different perspectives. Regulators were concerned that if, regulations become much more complex, it'll be that much more difficult to understand and comply with them. I think operators were probably the most pro-regulation that we heard. The battery industry, as you might expect, was not pro-regulation. And then e-commerce, basically admits to exploiting the gaps in regulation, within their business model. So I think we did, though, pretty consistently. I think over 50% of the recommendations from our stakeholders dealt with either regulation, oversight, and enforcement. So I think there, to me, seems like the right place to start. Like, how do we strengthen enforcement for the regulations that already exist? How do we improve oversight so that it's not left to the individual operator? And then I think related to that, possibly like shipper training.
Hi, Emily Pia from Label Master. A question on especially the model regulations. A lot of the goods come from China or Asia. They come by ocean in freight containers. They're not at 30% state of charge. They hit US, they go to the DCs and everything else, and now they go on airplanes. But they're not. Is there, I know you guys are kind of thinking about getting the ocean, starting to look at the ocean mode and how things come in there. But that is a huge gap, and it's happening every day in the DCs, because now these things get repacked, they're not at 30% state of charge, and they go on airplanes, and it's happening every day. So, I mean, how do you solve that? Well, I think, that's something that we're hoping to investigate. So, TRIP started as an aviation-specific program. We are now looking at, multiple modes of moving these batteries through the globe. But, one of the things that we heard pretty consistently from stakeholders is that the regulations differ too, from trucking to shipping to aviation, because there are just totally different risk profiles. And so things that are originally packed for, trucks or ships, that's actually where a ton of risk is being introduced in the US with these small shippers, because stuff is coming on the boat, like you said, to their, they're getting it, and then they're in LA putting it on an airplane. They're putting it, frankly, like often in the post office, so it's going on a passenger flight. And we need to better understand the interaction before I think I could make any, recommendation there. No, and I know, like, a lot of the ocean carriers are, because of the fires that they've had lately, they are asking you or telling you, we will not accept your goods unless they're at 30% state of charge. Right. But it's not a regulation, so it's kind of a hit and miss. Again, it would be great if everybody just said, hey, let's just do this. But I'm looking at the regulation.
Yeah, if I may react, I think the example you gave, Pia, is indeed very interesting. Involves multiple modes of transport. But of course, if the regulations are followed for one mode of transport, there is compliance, so that links to the regulation. and to safety oversight. But if then, with going to another mode of transport, people do not follow the regulation, then the third pillar that you mentioned comes into play, and that's the enforcement. And I think this enforcement is probably the most deferred organized within regulators, meaning that in some countries you will be punished, in others you won't. And I think, speaking as a regulator, I see that also as a very difficult situation. Yeah.
With that, maybe I'll turn it over to Remco since I'm out of time.
There's one more question for you.
Oh, sorry.
Sorry, just one more comment. It's more of a comment really than a question, but it links, Ben mentioned it in his presentation. IATA runs a program called CEIV Lithium Batteries. I'm a validator on that program, and a lot of the companies which are validated are freight forwarders. Exactly what Pia mentioned, consolidation is all freight forwarder business, right, across all different modes. And this particular freight forwarder, who, according to the 2025 statistics, was the biggest freight forwarder, one bought the other, so you can do the maths, actually did a detailed case study on who is their customer. Who is really the customer? And they did a real deep dive into that and were able to identify some key source locations of where the consignments were coming, and they held workshops with them in Asia to help them prepare that if you're shipping multimodal that is going ocean into this country and then onto air, you need to prepare already for air at origin at ocean. Yeah, and they were able to demonstrate through, because it came up as a part of the corrective action plan in this particular case, and they were able to demonstrate the case study and actually really demonstrate the preparation at origin before ocean. It was a great example, and that's where, as an industry, we need to get to through training, awareness, visibility, all of these things. And I think the work you're doing is fantastic, and I think that will really help, you know, the supply chain as well. But that was a nice example. Thanks.
Thank you. Oh, same one there.
I'm Jeff Kale from Global Canine Protection Group. I have a question and then just maybe a comment. Are the incidents that occur, like the ones you showed for in Hong Kong and in the Pacific, are those declared? Those were declared as, did they package that way as Class 9s, and are there, is there any part of undeclared? Like,
yeah, no, I mean, we have the data, so I can connect with you afterwards, but I think about 67% of the incidents were marked and labeled according with regulations, and then others were not. So I think when we have incidents reported, it's any incident that was detected by one of our trip members that reported it to us, whether or not it had been declared. They'd, obviously had to address the incident.
very good. And we have a solution for undeclared, if anybody wants to talk later. We have dogs that can do this, so.
Okay, great. Well, yeah, and actually, I mean, a screening conversation would be fantastic to have too, because I think there's a lot there. I think that's another a place where we heard significant variation in, approaches to screening, whether it's something as, I guess I'll call it low tech as dogs, to high tech as, AI predictive models of, non-compliant batteries in a shipment. I think there's a lot of work and I think harmonization to be done in that space as well. Thanks.
So thank you, Emily, for the presentation. Well, first of all, Ben, thanks for setting the scene and give us some history lessons, let's say. And then Emily for the keynote presentation, a really well given presentation, visually attractive, and I think it also gave a very good overview of what actions could be taken in the future related to this topic. I was asked to give you some information about new battery tests that are being developed. So I will guide you through it. It is maybe a bit different than the previous presentations. It gives you an overview of what will be happening in the future, or what will be a new classification system for lithium batteries. Now, Ben already gave us some information on incidents and accidents that happened. And that will be certainly part of a short start of my presentation with the history. Then I will go to the basic principles of this new classification system, shortly talk about the test protocol, then go to the classification scheme itself, and then make a short conclusion. Those who were yesterday at the cocktail hour in our session linked to the safety of the supply chain will have seen that I also gave a presentation on safety of the supply chain, where we discussed the definition of safety. And I think it's important also to remember that all actions that Emily described and that I will describe on new testing is related to improve the safety of lithium batteries by air. It might sound logic, but I think it's very important that we have this in mind, that it's not something that was invented to change something, to keep us at work, let's say. It's because incidents have occurred, and that it has been seen that these new tests will probably improve safety for the transport of lithium batteries by air. Now, the incidents and accidents that occurred led to decisions by the ICAO Dangerous Goods Panel, or by ICAO in general, to ban certain shipments from air transport and to limit certain transports very strictly to having to have an approval or having to have more strict packaging and more strict conditions. Now, what you see on the screen are actually all the UN numbers that are linked to lithium-ion batteries, lithium metal batteries, and those contained in and packed with equipment. The ban or the limitations that were introduced by ICAO led also to discussions from certain sectors that said that their batteries are used, for example, for medical purposes. Batteries are used in environments that are high demanding, with high temperature or with a lot of movement. And they said in those environments, those batteries, we cannot afford having incidents with those batteries, and we can actually prove that our batteries are much safer than others. This being said, the intention was actually to be able to separate the safer batteries, the safer lithium-ion batteries or the safer lithium metal batteries from the unsafe one. But it was not possible, linked to the classification system that we had. So the question was, where is the granularity? If you have a certain chemical composure of a battery, how can we differ that from another chemical composure of the similar type of a lithium-ion battery? So that was the original intention, to create granularity and to separate batteries that could be proven to be safer from others, to be able to transport those via air. Now, this was also already a request in 2016, so a long time ago, where the ICAO Dangerous Goods Panel actually requested the UN Subcommittee of Experts on the Transport of Dangerous Goods to start a working group with a mandate. You could ask the question, why is this going to the UN Subcommittee? It's because of the classification of dangerous goods is done on a multimodal level, so it would not have made sense that ICAO had started it itself. It should have been going indeed to the UN Subcommittee. So the mandate was pretty clear, but quite general. So prepare a hazard-based system to classify lithium batteries for transport. And I want to note it's clearly hazard-based system, linking it to the hazards of a particular battery. Determine the inherent hazards represented by lithium batteries and the types of reaction that may result, and also consider then destructive things. Important to note And I think that's also linked to the previous presentation. I think some sort of safety promotion is needed, or visibility, as it was said by somebody of the room. It is important to note that currently there are clear requirements for the transport of lithium batteries. You cannot put any article on the market and transport it without having to fulfill these requirements. So I highlighted a few of them. So the first one says it has to meet the requirements of each test of the UN Manual of Testing Criteria, Part 3, subsection 38.3. I will come back to that later, but Ben mentioned actually when this was introduced and that these tests exist. Each battery needs to have a safety venting device or designed to preclude a violent rupture. These are standard conditions that exist currently if you want to transport batteries. You have to have a means of preventing external short circuits. You have to prevent dangerous reverse current flow. And then I think the most important one, it has to be manufactured under a quality management program. If you do not fulfill these conditions, you are not transporting lithium batteries. That's how it's defined in the regulation. And of course, it manufactures under a quality management program. We could link this then to the oversight. What do regulators do to see indeed if this quality management program exists? So the 38.3 testing that exists already, I listed them here, are actually robustness tests. So it's T1 to T8, just a code. And I will name a few. We have an altitude test, thermal test, shock test, a crush test, an overcharge test. So these are quite severe tests that lithium batteries must, these tests must be applied to those lithium batteries before you can transport batteries. And also to be clear, this is not only for air transport. This is multimodally needed before you transport batteries. So if there would be somebody in the room that thought that currently there are no regulations to be followed or no tests to be done, I hope I have convinced you that this exists for a long time in history, and that if you fulfill these requirements, your batteries are considered to be safe for multimodal transport. Now, going to the new classification scheme. Like I said, what was the issue? We could not make a distinction between the better batteries or the worse batteries. Now, we all know that a reaction that occurs with lithium batteries is thermal runaway. So the idea was to look at a unique set of tests where you go actually forcing the lithium batteries into thermal runaway and see what happens, which actually means that if you look at the reaction, you can make a distinction between batteries that react very hard and those that do not react as much. Another hazard is the thermal runaway propagation, meaning if you have a battery that goes into thermal runaway, you put it next to another battery. And to be clear, when I say battery, it's also cells, but just for the ease of speaking, I will use only batteries. When you put them in a package, and there is propagation, of course, then you could say that battery is less safe to transport than a battery where there's no propagation. If one battery goes into thermal runaway and it doesn't propagate to another battery, you could say that those batteries are then safer to be transported. Thirdly, a high temperature reaction. So thermal runaway goes together with high temperature, and that was also a hazard that we looked at. And then significant quantities of toxic and or flammable gas, something that's, of course, really important for air transport. So that's also a hazard that's applicable to lithium batteries and where we looked at. And when I say we, there's a subgroup of the UN subcommittee that I'm chairing that looks at these new tests. And well, already for long periods, but we are getting closer to a final decision. And that's also why I'm presenting here today the classification scheme. So based on these new based on these hazards, a new testing protocol and a classification scheme was proposed. So without going into too much technical details, I'm going to describe first the test protocol as short as possible without all the parameters that on temperature, etc. I'm not going to talk about that because, of course, there are standard temperatures you need to have, standard pressures, etc. So remember the tests that I showed you, T1 to T8, the robustness tests, they still exist. So we decided to name the new tests T9 and then going further. So the new test T9, T11 is actually looking at propagation of thermal runaway. So as you see on the picture, you put batteries next to each other. One of the batteries you force into thermal runaway. What happens? Is there thermal runaway? Will there be propagation? And then you can measure high temperature, gases, etc. The testing based on failure is quite unique. Secondly, the tests that we saw from battery test institutes indicate what we already knew in air transport, that the state of charge has a big influence on how severe the reaction is of thermal runaway. So it was decided that the batteries can be tested on the state of charge that they are transported. Meaning, if you test the battery on 100% state of charge, or you test your battery on 30% state of charge, the outcome of the test will decide how you can transport your battery. The last bullet point is linked to the test for the gas volume, but I'm not going to go into detail about that. I think the first test, T9 and T11, which is for cells and for batteries, is the most important. Now, looking at this scheme, I'm going to run you through it. It will be probably difficult to read, but it is actually the classification scheme as it looks now. But to be clear, it's not yet finalized. It's still under review. But my idea is that it will not change that much anymore. So, to go with you through the scheme, we first look at the top. The top set says what I explained in the history, meaning the T1 to T8 tests, they still exist. They still have to be done. Robustness tests, nothing will be changed with that. And then you have an option. Or you do the additional tests, the propagation test, or you don't. What I highlighted here is, on the right side, the no, so you don't do the additional tests. Then you will be seen as the most severe battery to be transported, so the most dangerous battery to be transported. So that's a choice that manufacturers can make to say, we do not do the additional tests. It means that you will have to follow the most severe, you have to apply the most severe packagings. It also highlights that the existing classification scheme, so the UN numbers that I showed you, will remain for a certain period. But when the new system has been applied, it will be a transition period until the with a phase out for that old system. Now, if you look to the left, meaning that those additional tests, the propagation tests, you do that. So you force the battery to thermal runaway, and you see now on the left, it says there's no thermal runaway reaction. What happens? You go to the box on the bottom left, and it says, have you tested your battery on fully charged, so on 100% state of charge. If you did that, so you have your battery 100% state of charge, you applied the new test, forcing it in thermal runaway, and there was no reaction, then the working group decided that it would be a non-regulated battery because there is no hazard. If you have tested it not on 100% state of charge, you will be seen as a battery that is less severe, has less reaction, and it will be a type D, meaning that you can apply less severe packaging for this battery. Now, if we go to the decision box on thermal runaway, the test is being done. You see, you force the battery into thermal runaway. The next question is there propagation or not? Like I said, if there is propagation, you will end up with a type A, so the most severe battery to be transported, meaning also the most stringent packaging conditions you will have to apply. Now, I already mentioned, if, of course, you do not have any propagation, it means that if there would be a thermal runaway, it would only be one battery in the full package that has a hazard. Then comes the flammable gas volume hazard into play, where, depending on the quantities, more than 25 liters, less than 0.5 liters, or between, you will have several types. Meaning, of course, if you have lots of volume of the flammable gas, you will be as a more severe battery and also have to apply more stringent conditions. And so actually, going through the scheme like this, we go back to the full scheme, and that's what I explained. So you go from the left side to a completely not regulated battery because of the fact that if tested for the new tests, there is no thermal runaway, and you have tested on 100% state of charge, there is actually no risk in transport. And to the far right means if you test the battery the new test, there is a thermal runaway, there is propagation, meaning you will have to apply more stringent packaging conditions. Now, to conclude, it is quite a unique approach based on the mandate that was given to the UN subcommittee of ICAO, the UN subcommittee of Experts on Transport of Dangerous Goods. Because of that mandate, asked to look at hazard-based classification system for batteries. It is quite a unique battery testing protocol based on failure. Secondly, the state of charge, which we already apply in air transport as a mitigating condition, is also now acknowledged on a multimodal level as a way to reduce the risk and as a way actually to classify your batteries as another type. And then, of course, it's part of the conclusion. I didn't mention it in the presentation. When the new testing is actually looking at thermal runaway and propagation, if you are able to apply packaging that makes sure that you do not have propagation, you of course already eliminate a risk. So the packaging mitigation risk of propagation will be a very valuable thing. And currently, packaging manufacturers are already looking at these kind of packagings. And even the big battery car manufacturers already have this to ensure that if they transport their batteries in big volumes to the car manufacturer facilities, that if something goes wrong with one of those cells or one of those batteries, that not a full pallet or the full container is gone. So they apply already gaps between their cells and batteries. So this will also be a very important aspect. Lastly, I think it's clear, at least to me, I hope I made it clear to you, that more granularity is needed to ensure the safe transport of lithium batteries by air, and that was really an answer to the mandate that was given by ICAO to the UN subcommittee. So with that, as I mentioned, it was maybe a little bit different presentation than the previous ones, but this will be the future. I cannot say yet when, and I also want to make clear what you saw now is still under review. It has not yet been approved by the subcommittee in total, but this is the way it is going, and I think 80% what you saw now will probably still be there, will only be a little bit tweaked, and I hope in the near future this will be applied and can make the transport of batteries safer, especially by air. So thank you.
Any questions specifically for Remco? We'll start over there.
Thank you very much, Patrick, Special Cargo Services. Remco, we briefly addressed it yesterday as well. And the UL standard also addressed this in a way. The regulators, how are we going to make sure that the testing is done by companies who are actually performing the test correctly? If I remember well, we also talked about explosives being classified. That can only be done by companies who are allowed to test explosives to be classified. Is there any idea on how we're going to regulate that?
Well, thank you for the question. I think currently the T1 to T8 tests are done by the battery manufacturers themselves. They need to be done under the quality management program, which I highlighted in the history list, let's say. So the way that it will be organized, or that it will be how it will be implemented, is that the tests will be added to the quality management program that needs to be there before you can indeed transport or manufacture lithium batteries. So depending on how the oversight is done in every state, how this oversight is currently done for T1 to T8, it will be similar. Yeah.
Can you hear me? Yeah. My name is Stef Meijvoet from Trip & Co. Coincidentally, similar name. You described the regulations and tests. Those are applicable to the batteries themselves. Can you elaborate a little bit on the regulations and the tests for the packaging materials and the containers that the batteries are transported in?
Yes. Well, I deliberately took that out of the presentation because that's still under discussion. I will try to briefly explain why. So the mandate came from ICAO for air transport, but the UN subcommittee have never acknowledged that the current transport condition of batteries are unsafe, meaning that for other modes of transport, applying now more stringent packagings compared to the current packagings is seen as an unnecessary burden because of the fact it's not seen as an unsafe way of transporting batteries now. Looking at that from another perspective, and understanding now that batteries on the far right of the classification scheme have high temperature risk, will propagate severely, and have a large volume of flammable and toxic gas, people from the subcommittee say we cannot ignore this condition. Or this hazard, sorry. So that is still under discussion. How it looks like now is that on a multimodal level, the current packaging conditions will remain as the standard packaging for the most severe batteries, and that there would be more relaxation of packaging conditions for the less severe batteries. Now, we are here, of course, in a aviation, and that will be a decision to make by ICAO and the ICAO Dangerous Goods Panel, as we have done in the past with lithium batteries. We treat them quite differently compared to the multimodal recommendations. And when I say quite differently, it's purely linked to what you mentioned, the packaging conditions. So there is a big chance that aviation will indeed continue to say that for certain batteries you will need other packaging than you do it multimodally, and or say that certain type of batteries, for example, the most severe batteries, will not be allowed for air transport. And then, of course, the mitigating measures come into play, where if you are a type A battery when you are tested on 100% state of charge, but if you transport it on 30% state of charge, you have no propagation, maybe air transport will say, then we allow them. What is actually currently the standard for batteries to have it on 30% state of charge. So I hope that answers your question partly, but I cannot say yet what will be the final outcome of the packaging conditions, only what has been discussed until now. Sorry, I didn't hear. Yeah, so you ask what the timeline is of the final outcome. Well, the regulations work in a biennium. So if we finalize this biennium, and that is a possibility, but not a certainty, then it would become applicable in 4 years for air transport. If we do not finalize this biennium, it will take another 6 years. Yeah. So that's the current situation. Any other questions?
Thank you, Remco. I think that's... Yeah, so let's go ahead and roll into our last session of this panel, and this one is called a panacea for battery safety. So if you're like me, you had to look up and see what that word meant. Nice choice of words there, Ben. But you know, I think we all would agree that there is no magic pill or one global solution for battery safety. I think that is something we all can agree on. But how do we expose the gap between regulation and reality? You know, how do we deal with the conflict of wanting portability, increased energy, and also increased safety, and also cost? You know, so I invite the audience to engage. This is the audience participation portion of the panel. You guys have done a pretty good job so far, but I'm sure there's other questions. I have a whole list of questions up here, you know, probably 40 or 50 that we can work through. So I'll open it up first, see if there's any burning questions, pun intended, that you all have that you want to get out before the panel is over. Otherwise, I have a few saved back. So anything offhand? Okay, state of charge is still a little low. We'll work on that. So I'll lob one up for the entire panel to chime in on. What do you believe is the single biggest misconception the industry still has about lithium battery safety? Like, what does the industry still not get? What is the misconception? And Ben, it's been a while since you gave your presentation, so we'll start with you.
My state of charge is still low, Tim. But I think, from my perspective, the biggest misconception is that if I'm buying it on the internet and I see two products side by side and I can buy one for cheaper, there's no difference in quality, there's no difference in performance, it's just price. That's it, and I will buy the cheaper one. So if I've got a choice between two power banks, two batteries, one's $50 and one's $30, I'll go for the $30 one. I just go by money. I actually don't think about quality. I don't think about the likelihood that my cheap replacement battery for an e-bike might actually burn down overnight and destroy the house. My brain just doesn't go there. The assumption is if I buy it, it must be safe. Because there's regulators out there. There's consumer protection bodies out there. They're looking after me to keep me safe. That's where I see the biggest misconception. There's somebody else doing the right thing. And when Emily interviewed me, I made the comment that lithium batteries aren't an aviation problem. It's a consumer product safety problem. She stunned me with the answer that everybody else said that it was somebody else's problem. And that's where I've had to change my thinking. It's no longer somebody else's problem. It's all our problem. So to come back to your question, the biggest misconception is somebody else out there is doing the right thing. It's safe, and I can buy the cheapest version going.
No, and I'll chime in on that too. Just a quick thought. I've had this conversation with several people. It's like when you go to buy a power bank, you know, it's a different mindset picking on power banks, but they're not here to defend themselves. Picking on power banks, like when you go buy tires for your vehicle, does anybody pick the cheapest tire? No, I mean, when you drive, for those that have a vehicle and you drive, you instantly think, well, the cheapest tire that's available is probably not the safest. And nobody likes to buy tires. They're expensive. But you don't buy, at least me, hopefully you don't. If you do, I don't need a ride back to the hotel. You know, you don't buy the cheapest tires. So it's a consumer mindset. So no, I think that's a fair point. Remco or Emily, do you all want to chime in on what you think biggest misconception is?
Well, I would actually just add to what Ben said and say, in addition to kind of consumers not understanding the difference and shopping for price, there's a behavioral element with sort of consumer use of these devices, but I think also a behavioral element in the supply chain as well. So these devices are not the same as, you know, a piece of clothing that may come to you and it turns out it's poor quality, although we're learning more about microplastics and stuff, there's risk there too. But, you know, if you drop it, you can cause a major issue. If you charge it with the wrong charger, you can cause a major issue. If you have an Apple phone or a Lenovo laptop and you buy a cheap charger online for that product, you can ruin that product too. And so there's that behavioral element there, which is why I think we're particularly concerned about refurbished and used batteries going into the supply chain. But there's also a lot of behavioral elements in the, you know, journey from OEM to the end user. Anything from how sterile is the manufacturing environment, how hot is the tarmac that the package is sitting on, how cold is the tarmac that the package is sitting on, what temperature changes are the batteries experiencing during their journey around the world. Did the box get dropped off the conveyor belt? Did anyone check if it had a marking on it and, you know, investigate it further? I mean, these are products that are largely very safe, right? We are surrounded by them constantly. I do think that that actually diminishes our understanding of their risk in some ways, kind of like driving. Like getting in a car is the riskiest thing any of us do on a day or a given week, but we do it so frequently that we don't perceive it as a particularly risky event unless something happens. I think the same is very much true with batteries, not only with the consumers, but also how they're moving through the supply chain.
Yeah, if I can add to that, I want to say the same thing as Ben, saying that indeed not the biggest misconception in industry, but more in general, the biggest misconception is that it's indeed somebody else's problem. I think batteries are used by everybody, and there are not a lot of people that know what you just described, Emily, that yeah, if you handle your battery in a wrong way, you can have a catastrophe. And that's also why I think that the safety promotion is important, and that getting that information out to, let's say, the regular public, so not the safety experts here in the room that know that batteries are indeed dangerous if you handle them miscorrectly or use them incorrectly, sorry. But that the consumers also know that there is a risk in how they treat their power banks and their batteries, etc. So I think that's maybe the biggest misconception in general, that not everybody understands that it's your problem also, and not only from the regulators or only from industry. And I also want to link that to, for example, a regulatory organization like RCEA, convincing people that the safe transport of dangerous goods is important is not that difficult. It sounds the safe transport of dangerous goods. I don't have to explain my boss why this is important. And I guess in a private entity, that is also very simple. But then explaining that the batteries that you are using are also considered dangerous goods and are also part of that system, that is something that's really difficult to explain to my boss or within an entity, because it's so common, everybody uses it, and nobody realizes that these are actually also considered dangerous goods for a good reason. So that's my answer.
Quick check. Any questions out here? Okay. So, Emily. Again, these are not pre-planned. This is fun.
I'm nervous now.
I know. Oh, I
already had to think of what batteries would say.
Well, yeah. That was my favorite question. I already used that one. I broke that out early. So, Emily, in your research, which part of the supply chain, in your research, you gave a lot of, information and all that. What does current data not tell us that you wish you had?
What I wish I had, and I'm lobbying my supervisors so I can do this, is a better understanding of the ways in which batteries move through the supply chain, through the multimodal system. I also wish I had more data on what proportion of batteries we think are non-conforming and fall into various categories of non-conforming, so that airlines and regulators could actually better model the risk and develop regulations and policies that would address what we think is happening with these non-compliant batteries, non-conforming batteries. I don't know how we get that data. I mean, my understanding from the maritime landscape is that it's much harder to capture there than it is in aviation. I think it's going to be a lot of predictive modeling, but I think that even that would potentially be a good grounding for some of these conversations to continue.
Okay, Remco, your turn now. Do we have one out there? Do we have a question? Okay. Get a mic.
Yeah, it's working. Now, just to add to the discussion maybe, and I don't know if you got an answer for it, but I'm a private person. I order a power bank with Amazon. It flies in, it comes to my home, and it's broken, and I'm allowed to send it back within a month. Put it in a box, give it to UPS, FedEx, DHL, whoever, and then what? And this probably happens tens of thousands of times a day, but it's a broken battery that's going to be shipped back. Is there any ideas on how we could prevent this from happening?
And so you said it doesn't work, it's damaged or defective?
Yeah.
Well, I would suggest you would use either FedEx or DHL. That's my first suggestion. I would also suggest you send it back ground. Well, I mean, that's a tough question. I mean, I don't want to just go to the easy answer and say it's consumer education and all that stuff. But I mean, that is a large portion of it, is that, reverse logistics, damaged, defective, recall batteries, sending things back, all those pipelines. I mean, those in the industry, we know all about that stuff, or at least we know enough about it, what to do or know who to ask. I mean, general consumers do not know that. People in my own house do not know that, I'm sure. I don't go home and talk about dangerous goods. It's, hopefully not a whole lot of people do. You may be living by yourself soon. But it is consumer education. I mean, there's so much that is needed on that aspect. I mean, there is stuff out there about vapes on airplanes now. There is stuff about, power banks not in checked baggage and stuff. But there has to be so much more education, public service announcements. I mean, governments need to my opinion, governments need to take some of their tax dollars and use it for that educational purposes on if it's swollen, if it smokes, if it smells, if it doesn't work, it's bad. Don't just stick it in a box and ship it. I mean, that's just my opinion. If anybody from the panel wants to chime in.
I'd say it's similar to Emily's research. When you're dealing with, and maybe Amazon's not quite the example, but when you're dealing with a large reputable manufacturer that needs to do a recall, and we have seen it, they get the recall cannot be done by air. They understand that. And so where it's a large organization, you've got good confidence that they will do the right thing, and it's at the point where it's already factored into their pricing of, thank you very much, sorry Patrick, that your power bank isn't working, please dispose of it locally and we'll send you a fresh one.
That's me. That was the question I have. So if you live in the US, you have no idea how to get rid of a battery. But if you go to Europe, in every store that you walk into, if you go to DM or something like that, when you're checking out or there towards the door, there's always an option for drop your batteries here. Actually, just in London, there was a drop your vapes here. But in the US, literally, people were probably throwing that battery that didn't work, if they didn't return it, into their trash can with all the rest of their trash. So it's also a huge gap and an area that maybe, eventually could be researched.
Yeah.
In addition, I'm sure this happens everywhere, but we have a large procurement industry in the US. So the government often procures a lot of things for embassy support. They'll procure 1,000 laptops, and they will sit in a warehouse sometimes for 1 to 10 years. And so it's just been sitting on this shelf forever. And then they're like, well, now the technology has surpassed, you need to get rid of them. And no one really knows what to do with this 1,000 laptops that have now never even been turned on and have exceeded the technology shelf life. So
I think that's a great point. I would note, too, that this issue is not going away. It's only going to grow. I mean, circularity is something that we're focused on really significantly at ULSE. Lithium is a finite resource. Obviously, battery technologies are evolving. There are other chemistries that are sort of coming online. But, it's been 30-plus years of sort of the rise and primacy of lithium-ion batteries. I think even if another technology comes on board, it'll be another 30 years before that's really replaced lithium in our batteries. And I'm sure it will introduce new risks, too. But the fact of the matter is, I think manufacturers and governments are increasingly interested in recycling those materials for circularity reasons. And so I think the cargo industry is going to need to develop solutions for that sooner than later, frankly.
Question there in the middle.
Hello? Okay. Good morning. Thank you for some application you did on lithium battery. As a shipper, I have run into different issues as to lithium battery when we have to do it through the passengers' flight. So I'm trying to have an understanding that for each cargo, what is the maximum lithium battery that one is allowed to put in each cargo per passenger flight? That is one question. The second question is, I have a package with FedEx for the last 6 months, which they clarified to me before shipping is going all the way to Africa. And they told me it's UN 3490 lithium battery. They told me it's accepted. I shipped through them and holding it from Atlanta to Nigeria, but they held it down in Mississippi and it's still sitting down there. I have called them blue in the face. Eventually, after 2 months, someone responded back to me and saying that maybe invoice issue and things like that. And I'm saying, okay, can you return the goods back to me because it belongs to a customer? And yet to receive it. And it seems like I have to go through legal procedure to get my package back. This is a package that is over $2,000. And I was told that they are able to ship it And I went through my account to do all of that. And this is a, I believe, multi-million organization that are not responding to calls, email, or returning my package back so I can send it back to the owner. So at one point, does someone actually know the next thing to do when it comes to lithium battery, especially when your package is being held down or airline is rejecting it?
Actually, my gut answer on that is I think maybe maybe we should take that one offline. Let's
I'll give it a bit of a go.
yeah.
So sitting in IATA, we have an email link, dangood@iata.org. And part of the problem I have is people who write to me and say, I want you to referee the dispute between me as a shipper and somebody else as the freight forwarder. And part of my answer is that the rules are there for everyone to read and interpret and apply. And from my perspective, I can give my view, but it's my view. It's not an IATA position, it's just how I read the rules based on 30 years of experience. And the encouragement I give, particularly on rejected shipments, is you're dealing with a person and you're getting the same answer and you're convinced you're right and they're wrong. Well, you need to find a different person to speak to. So you ask them to have a manager or a peer review it, but also talk to your own training organisation that trained you to make sure that you're on the same ground. And you just have to work your way up the management chain until you get an answer that you're actually more comfortable with. So I appreciate you're in a very difficult position, but you've actually got to keep working with the company that's currently got your product in wherever it was. That's the first one, is there's an escalation process. And eventually you'll end up high enough that somebody will say, look, let's just send it back by road for whatever reason. Or they'll look at it and say, yes, whoever it was at this intermediate port has made a mistake, they've stopped it for the wrong reasons, get it moving again. So that would be my encouragement there. Keep working with the company that you've shipped it with. And then I think your other one was about how many batteries you can have in your baggage. It's checked baggage. It's batteries by themselves, it's 0 when it comes to lithium batteries. We actually don't want them in there. As I touched on in my presentation, one power bank was enough. So we don't want any in there. The reason why we want them in the cabin is that we do have cabin crew who are trained to respond to incidents, so that if there is a thermal runaway in the cabin, there are people that can deal with it immediately. That's why the rationale is we want them in the cabin, not in the hold. Thanks, Tim.
Coming up close to time, I did have a rapid fire lightning round that I was going to do as a surprise. So luckily for them, they do miss that. But I do have one question I do want to ask on that. One question, it's one word, and we'll go quick. We'll start with Ben. What is one word that describes today's battery landscape? One word.
Complicated.
Remco.
The same question.
Yeah, same question.
Complex, is that a different word?
Okay, no, that's fine. These are quick.
I'm going to go with proliferating.
Okay. All right, I got one more. Let's do one more. Biggest risk, and we'll start with Emily and go down. Biggest risk, manufacturing defects or misuse?
I think misuse.
Okay, hey, there's no right or wrong. Remco.
Misuse.
Okay.
Yeah, misuse.
Okay. Okay. All right, let's do one more. It's fun, right? This is fun for me. One more. Which is more dangerous? We'll start with Remco. More dangerous, ignorance or non-compliance?
Ignorance.
Ben?
Oh, I'm going to go deliberate non-compliance.
Okay.
I mean, my research shows there's a lot of ignorant non-compliance, unintentional non-compliance. So it's both, really.
Okay. All right. I get. You have a question? Okay. Real quick. Yeah.
Tess. So, and it may have been mentioned already. So is, at least some of the presentations I've seen, it's the non-conforming batteries that seem to be the bigger part of the issue. We talk about ignorance, we talk about misuse, but from an acceptance standpoint, I'm a cargo agent at the counter, accepting cargo. I'm looking for a UN number. You know, you got UL listed, the UL equivalents, whatever they are, European, Asian, I suppose there's many. Has there been consideration given to applying a UN number to a non-conforming lithium battery that would just be universally unacceptable? If it's this UN number, the manufacturer has to put that UN number on it, shipper, everyone in the process, we see that, we reject it. Has that been brought up or considered, or is that just so far outside the norm?
Who wants that one?
I can answer that question. No, that has not been considered. It's a classification system is based on compliance and on conformity. So having a UN number to identify non-compliant batteries is completely out of the box that the current system works. But I can imagine indeed if that would exist, it would help you. But I think a non-compliant battery, most people that send non-compliant batteries will not want you to know that they're sending non-compliant batteries. So I think that would not work. No.
Yeah, I've always asked for, as an operator, I've always asked for shippers to, you know, write on the outside of the box, undeclared. That would really help a lot. So, so I did have a tremendous closing. We're up against time, so I'm going to skip that. I do want to thank the audience, first off, for participation in the questions. Excellent job. You all have passed. Thank you to the panel. Really appreciate all the journey through the past, present, and the future. Thank you to IATA. Thank you to the sponsors, ICICA again for the session, and LATAM Cargo for the whole entire World Cargo Symposium. And, you know, one quick reminder for those that are probably getting out of town today, safe travels, and don't put your power banks in your checked baggage. So thank you all. Appreciate it.
Thank you.